Hello everyone, today I Arpita Sharma.
And I, Jagriti Bhatt.
Today we are going to explain the procedure for formation of nanoparticle in laboratory condition. So here are the material required mentioned. So for nanoparticle formation, material required are as follows. First one is precursor for nanoparticle, that is we can take zinc sulfate, silver nitrate or iron salts. Second is reducing agent such as sodium borohydride, plant extract for green synthesis and etc. Third one is stabilizing agent, for example polyvinyl alcohol and citrate. Next is deionizing water, and the last one are beaker, stirrer and hot plate.
So guys, going ahead for the characterization of the nanoparticles, we need the following things. First of all, we need a dynamic light scattering, that is a DLS equipment. Next, going ahead, we will be needing UV spectrophotometer. And the third one will be scanning electron microscope or the transmission electron microscope. Next, the fourth one being Fourier transform infrared spectrophotometer, and the fifth one being zeta potential analyzer. So these are the basically materials required for the characterization.
Now for application we need seeds or plant. For example, we can take wheat seeds or maize seed or rice seed. Next is soil or hydroponic setup. Next is growth chamber or pot, sprayer and nanoparticle dispersion, and last one is nutrient solution.
Moving ahead to the procedure of the nanoparticle formulation, first of all, method A, we will be discussing the chemical synthesis. So, dissolve the precursor in deionized water to prepare a 0.1 molar solution of the KCl. Next, slowly add the reducing agent under continuous stirring. The stirring is very important. Observe the color change indicating nanoparticle formulation. Next, add a stabilizing agent to prevent agglomeration, and moving ahead we have to centrifuge the solution and wash the nanoparticle with water to remove any impurity present, and at last we will be drying the nanoparticle at 60 degrees Celsius.
Moving ahead to the next method, that is method second, we can use Crete synthesis for the extraction of nanoparticle. First is extract plant material. For example, we can take neem or tulsi by boiling it in water. Next one is filter the extract and mix it with the precursor solution. Third, stir the solution until a visible color change occurs. And in the last, isolate the nanoparticle by centrifugation and drying.
So, next we will be discussing the characterization of nanoparticles. So, number one will be particle size and distribution. So, use dynamic light scattering DLS to measure the average particle size. And for the morphology, use SEM or TEM to observe the shape and surface characteristics. Next, for the surface charge, we can measure it with the zeta potential to stability occurrence. And the fourth one will be chemical composition. For that, we will be using FTIR, that is the Fourier transform infrared spectroscopy, to identify the functional groups on the nanoparticle surface. And the fifth one being optical properties, we will be recording the UV visual spectra to confirm nanoparticle formulation. For example, it can be the silver nanoparticle that shows a peak around 420 nm.
Now, we will be discussing the applications in agriculture. First is prepare a suspension of a nanoparticle in deionizing water. Second is apply nanoparticle to seed or plant using one of the following methods. First one is seed priming. Soak seed in the nanoparticle solution for 12 to 24 hours. Or we can use foliar spray. Spray nanoparticle suspension onto the plant leaves. Next one, we can use it as a soil amendment. Mix nanoparticle into soil or hydroponic solution. Third application is we can set up a control group without nanoparticle and an experimental group.
And then moving ahead, discussing the observation and the data collection. So, the plant growth. We will measure parameters such as the germination rate, the shoot to root length and the biomass. Next, on the basis of nutrient uptake, we will be analyzing the plant tissue for the nutrient content using atomic absorption spectroscopy, that is AAS. And for the pest resistance, we will be evaluating pest mortality ratio if nanoparticles have pesticidal properties. So guys, this was all from our part. Hope you have gained some knowledge from this. Thank you everyone.
Thank you.
Today we are performing the experiment on extraction of nanoparticles from bougainvillea extract using magnetic stirrer. For this we are using the top-down approach.
Materials required are magnetic stirrer, filter paper grade 1, funnel, measuring cylinder, beaker, pH meter, burette, sieve, KCl solution and magnetic bead. Firstly, we have to filter the bougainvillea extract by using sieve and then by using grade 1 filter paper. Take 30 ml extract and measure the pH of filtered extract using pH meter. If pH is more than 5, then maintain it by adding dilute acetic acid drop by drop, simultaneously checking its pH. Stop when the pH reaches 5. Similarly, if pH is less than 5, then add NaOH drop by drop to the filtered extract. Take 10 ml of extract maintained at pH 5 using measuring cylinder and transfer it into a beaker. Place the magnetic bead inside the beaker and put on magnetic stirrer for 30 minutes at 60 degrees Celsius and 650 rotations per minute. Now, add the KCl solution drop by drop from the burette while stirring. After 30 minutes, take the magnetic beads out and let the extract settle down before observation.
When the sample was observed against light, a thin layer of nanoparticles were observed floating on the extract.
Good evening, sir. Today we are going to explain about nanoparticle formation from plant extract, and for this we are using the extract made up of rose leaves. So let's start with the step 1. Firstly, we'll pluck some fresh leaves from the rose plant, and then we'll cut about 5 to 10 gram of leaves into small pieces. Now add these leaves into 100 ml of water. Keep this extract for about 5 to 7 days, and now after 7 days we'll take this extract to the laboratory.
Now in lab, we'll filter our extract with Whatman 1 filter paper. After filtering, take 20 ml of aliquot in a beaker and add few magnetic beads. Now set the setting of magnetic stirrer to 60 degrees Celsius and 540 rpm.
Now titrate the extract against 40 ml of 10 millimolar KCl for 30 minutes. At last, transfer it to a conical flask and store it for further characterization. Thank you.
Hello everyone, we are the student of section C1 and we were asked to make an assignment on formulation of nanoparticles, and the plant part which we have taken is the leaf of lens copper plant.
For this, at first we took the leaves from lens copper plant and we crushed them with the help of stone. And we crushed the leaves until it became a fine paste. After that we took 10 gram of that paste and mixed it with 100 ml of water and stored it in a container for 7 days.
To start with it. Then we took that extract to the lab and we filtered it with filter paper.
And then we poured the filtrate into a beaker. We took 10 ml of filtrate and then we took 40 ml of KCl as a titrating agent, and we put that KCl into the burette and we used magnetic stirrer there.
And we kept the magnet inside the beaker and kept it over the magnetic stirrer. This magnetic stirrer is set for 30 minutes at a temperature of 60 degrees Celsius and the round per minute set at 540. And after the completion of 30 minutes, we put the filtrate into this flask and stored it. Thank you.
Now after 10 days, we have to observe the formulation of nanoparticles by passing the light through it.
Today we are going to perform experiment of preparation of nanoparticles using Acalypha leaf extract. In this we are using the top-down approach. Firstly, the material required are leaf extract, distilled water, glassware, magnetic stirrer and 40 ml 1 normal KCl solution. Now the very first step is preparation of the extract. For this we will take some crushed leaves. Here we have used a Acalypha leaf and then we'll put it for 1 week in 100 ml distilled water and the extract will be prepared. Now we will take a glass beaker and a filter paper, a Wattman filter paper, and we will filter out 20 ml extract. It would take some time to filter out. Till then, we need to wait for 10 minutes or we can stir it. Now, we will measure 10 ml of the aliquot and take it into another stirrer beaker. Now, we will take 1 normal 40 ml KCl solution into the burette, which will come down drop by drop into the extract or the aliquot we filtered. Now, we will place the magnetic stirrer and we'll switch on the magnetic stirrer and it will stir it for 30 minutes and drop by drop the KCl solution will be poured. After 30 minutes, we'll see our nanoparticles are ready. This is how our solution containing nanoparticles came out. This was a wonderful experience, all possible because of our teamwork. Thanks for watching.
We, the students of Section C1 here at Nanotechnology Lab, we were assigned for the formulation of nanoparticles using sample of plant part. For this assignment, we require sample, that is bougainvillea petals weighing 5 gram. The procedure is that the sample is taken and kept in 100 ml water for 2 to 3 days before conducting experiment. The sample is filtered using filter paper, 0.746 gram KCl in 1 liter distilled water, forming 10 millimole potassium chloride solution. Above KCl solution is dissolved in 800 ml distilled water to make a volume to 1 liter. Now take 20 to 30 ml extract and check pH. If pH is more than 5, then maintain it by adding dilute acetic acid, and if pH is below 5, then add NaOH to maintain pH approx 5. Then take 10 ml extract of maintained pH solution and place it on magnetic stirrer for 30 minutes at 60 degrees Celsius and 640 RPS for 30 minutes. Then simultaneously, drop by drop, 40 ml KCl solution should be added and right stirring. And after 30 minutes, close stirrer and check whether 5 layer is formed, reporting the solution beaker in 2 zones. Place the solution in test tube and close with the lid and label it. Then observe after some day whether nanoparticles are formed or not.
Today we are going to perform an experiment on preparation of nanoparticle using a bougainvillea extract. In this experiment we are using top-down approach. The materials are required are given below.
For this experiment, first we took the bougainvillea leaves and chopped it into the small pieces. And then that sample is prepared by soaking leaves for 2-3 days. That is strained by filter paper. 0.746 KCl in 1 liter distilled water is added to prepare 10 millimole KCl solution. 20 ml extract is taken to check pH. It is maintained 5 by adding acetic acid or NaOH. 10 ml extract of maintained pH is taken in a beaker and put a magnetic stirrer on it. The stirrer is set on 60 degrees Celsius and 650 RPM for 30 minutes. The burette is then filled with KCl 40 ml. Drop by drop KCl will fall on the beaker with extract. After 30 minutes, close the stirrer and check.
Now with this sample, when we pass the light through the plant extract, thin layer of nanoparticle can be seen, thus confirming the success of this experiment. Thank you.
हेलो एवरीवन, तो आज हम सेक्शन सी के स्टूडेंट्स नैनो पार्टिकल फॉर्मुलेशन वाला प्रैक्टिकल करने वाले हैं। तो सबसे पहले हम लोग हिबिस्कस एक्सट्रैक्ट को फ़िल्टर कर लेंगे। फ़िल्टर करके हमारा 10 मिलीलीटर हम बीकर में ले लेंगे, जिसमें कि हम लोग एक मैग्नेट ऐड करेंगे और फिर हम उसकी स्टिरिंग करेंगे। जो स्टिरिंग है वो होगी अगेंस्ट 40 ml KCl। तो यहाँ पे इसकी स्टिरिंग हो रही है और यहाँ पे टेम्परेचर, RPM और जो टाइम हमें सेट करना है दैट इज़ 30 मिनट्स। तो वो यहाँ पे हम लोग सेट कर देंगे। उसके बाद हम लोग इसको निकाल लेंगे आफ्टर 30 मिनट्स एंड देन हम इसको दूसरे बीकर में ऐड करेंगे और इससे हमारा एक ब्लू एक्सट्रैक्ट आता है जिसको लाइट से पास करके हम लोग नैनो पार्टिकल फॉर्मुलेशन हुआ है या नहीं हुआ है ये चेक कर लेते हैं। सो दैट्स इट।
नमस्ते, मेरा नाम अनुभव जोशी है।
नमस्ते, मेरा नाम दीक्षांत सकलानी है।
नमस्ते, मेरा नाम कनिका कन्याल है। नमस्ते, मेरा नाम शिफाली है।
आज हम आप लोगों को बताएंगे कि नैनो पार्टिकल्स कैसे फॉर्मुलेट करते हैं, वो भी एक एक्सट्रैक्ट की हेल्प से जो कि है एगल्फा। तो मेरे जो टीममेट्स हैं वो पहले आपको बताएंगे कि सबसे पहले प्रोसीजर क्या होता है।
पहले एक्सट्रैक्ट बनाने के लिए हम अकल्फा के लीव्स कलेक्ट करेंगे, उसे फाइनली चॉप करेंगे ताकि अच्छे से उसका एक्सट्रैक्ट बन सके। उसे एक क्रश भी करेंगे विद द हेल्प ऑफ मोटार।
फिर उसके बाद उसको 100 ml पानी में मिला देंगे और 7 से 10 दिन तक के लिए रख देंगे।
फिर जो ये हमारा लीफ एक्सट्रैक्ट इकट्ठा हुआ है इसको हम फिल्टर पेपर से 10 ml छानेंगे और फिर इसे हम 40 ml KCl के साथ टाइट्रेट करेंगे विद द हेल्प ऑफ मैग्नेटिक स्टिरर एट 60 डिग्री सेल्सियस फॉर हाफ एन आवर।
The RPM will be 540 and we will be doing this procedure for around 30 minutes as my teammate said. After this we will pass a laser beam and we will get to know whether nanoparticles are formed or not formed. Thank you.
Thank you.
हेलो एवरीवन, नैनो पार्टिकल फॉर्मुलेशन बनाने के लिए हमने लिए थे हिबिस्कस के फ्लावर्स। उसको हमने क्रश किया था अच्छे से और उसको हमने 100 ml ऑफ वाटर में डिज़ोल्व करके 1 हफ्ते तक रख दिया था। देन हमने उसको लैब में आके फ़िल्टर पेपर के थ्रू फ़िल्टर किया था। उसके बाद एक बीकर लेना था, उसमें 40 ml KCl लिया और एक अलग बीकर में हमने फिर मैग्नेटिक स्टेरर को डाला, 10 ml ऑफ द एक्सट्रैक्ट डाला जो हमने फ़िल्टर किया था और ब्यूरेट में हमने 40 ml KCl डाला। KCl ड्रॉप बाय ड्रॉप हमारा इस एक्सट्रैक्ट में गिर रहा था और जो मैग्नेट था वो कॉन्टीन्यूसली रोटेट हो रहा था और एज अ रिज़ल्ट हमें ब्लू कलर का नैनो पार्टिकल फॉर्मुलेशन मिला हिबिस्कस के फ्लावर्स का। देन हमने उसको कोनिकल फ्लास्क में डाला एंड देन हमारा जो फॉर्मुलेशन था वो रेडी हो गया था। हमने अच्छे से कवर कर दिया इसको एंड देन our formulation is ready. Thank you.